Hello and welcome back to the AWS Launchpad. We are live from AWS reInvent 2019 here in Vegas, and I'm here with two friends from the serverless team. I'm Alex Casalboni, technical evangelist with AWS. Would you guys mind introducing yourselves?
Definitely. My name is Amit Kulkarni. I'm a product manager on AWS Lambda.
And my name is Chris Munns. I lead developer advocacy for serverless at AWS.
And I'm Memo Doring. I thought we were friends, Alex, but apparently we're not.
Great, thank you, guys. We're here to talk about some of the performance improvements that happened in the last few weeks and the last few months. But we also have some interesting stuff that we want to announce, something
absolutely.
new, so stay with us.
Yeah, big launch.
Can you please tell us a little bit about what happened in the last few weeks?
Yeah, so back in September, we announced that we were going to be launching a really big change to how VPC networking works with Lambda functions. Really excited to say that as of last week, that has rolled out globally to all public regions. And I would say one of the biggest things that changed about how VPC networking with Lambda worked was a really significant impact to the initial cold start performance of a Lambda function. So for those who aren't familiar, the cold start time is basically the time that it takes for a new worker environment to be spun up and be configured and be able to execute your code. And so this had been maybe a rougher point on the performance spectrum for us. So it took a little bit of time to get this rolled out globally, but we're really excited now that it's out there in all of the public regions that we have. Customers should already be seeing the performance improvements happening for them. But we didn't want to stop there. And so with cold starts, it's a problem that we spend a lot of time trying to make sure that we're helping to address this for customers, come up with some unique ways to get around that. And so one thing that we're really excited to announce today, launching right now here, is a capability that we're calling provision concurrency for Lambda functions.
Wow.
And so again, right here, launching on Launchpad here on Twitch. And so provision concurrency, much like the name might sound, is a capability that will allow customers to effectively pre-create the worker environments that their functions execute inside of. And so this is going to help reduce even further that cold start penalty that you can have for a Lambda function down to double-digit milliseconds. So it's, again, a pretty drastic improvement.
Wow, that sounds great.
Yeah, it sounds great for latency-sensitive workloads, but what other workloads could it work for?
Yeah, definitely. So in terms of if we look at the space of our customers, they use Lambda for a variety of use cases. Anywhere from processing events off of Kinesis queues, to data transformations, to interactive microservices. I think provision concurrency is a great fit for latency-sensitive workloads. So if there are workloads that are very, very sensitive to tail latencies, latency of every single invoke, then provision concurrency is a great fit for them. So if you're thinking about mobile backends, thinking about web backends, things like that, for all of these types of workload, provision concurrency is the best fit.
Right, so if I know I will have a crazy spike in my workload that maybe I can estimate in some way, I can just provision as much concurrency as I need, and those functions will be warm. That's the idea, right?
Exactly. At the end of the day, more or less, that's it. So there's a couple different ways that this can work. There are some customers that know that they have a consistent amount of traffic that will flow over a period of time. And so you can use provision concurrency to basically address to make sure that you have concurrency available and performant for whatever your traffic pattern might be. Now we're also launching with auto-scaling support.
Oh, that's great. So if I don't know exactly how much we will need, I can auto-scale.
Correct.
They provision.
Correct, yeah.
That's great.
Now, Alex and I are evangelists. We do weird things. I thought we were friends, but we at least do the same thing sometimes, which is pre-warming functions.
Exactly.
I know that's kind of out there, but would this replace that?
Yes, ideally yes. So I would say that this concept of pre-warming is something that we've never treated as an official practice. We've shared guidance. We've worked with community heroes like Jeremy Daly, who have published actually I think the de facto blog post about how customers have done this. We see provision concurrency replacing the need for customers to do any of their own custom warming action. So you shouldn't need to run, say, a CloudWatch scheduled event to fire up a Lambda function to pre-warm some environments. You should just be able to use provision concurrency and get the same benefits.
Oh, that's pretty cool.
One thing I'll add to that is if warming works for you, we are not taking anything away.
Yeah.
In general, what we do see is that the results that you have with warming really depend on your workload pattern. So if you're perfectly able to warm in the lulls in traffic, then your warming traffic doesn't get intermingled with your actual production traffic. And but in a large variety of cases, we do see that this doesn't work for customers. And so we want to really provide a first-class mechanism where customers can keep a certain number of execution environments warmed, pre-initialized, and ready to receive invokes without having to do any of these other mechanics.
So I have a few applications myself, and I can start using this thing right now, right? In a few minutes,
by the end
hours.
Of today.
By the end of today, everybody can use it.
Gentle reminder, you're hearing about this first worldwide.
Yes.
This is an exclusive.
We're launching.
It's not quite out there yet, but today.
The big question is, do I need to change my code to use provision concurrency?
Yeah, you absolutely do not need to change your code.
Right.
It's a simple configuration. What you do is through console, command line, API, or any of the other tools, you just simply go set a number, a concurrency number on any function, alias, or a version. And you can't do it on $latest, you got to do it on a specific version or a alias. And then it takes a few minutes for the function to get ready. And once it's ready, it's ready to respond to your invocations under double-digit milliseconds. And all along, your code doesn't have to change. You can go set it for periods of times. On periods of times, you don't have to have it on there. So it's really up to you as to when you want to have provision concurrency enabled for your function and when you don't want.
Awesome. So what if I'm using AWS SAM or the serverless framework or other ways to deploy functions? Will I be able to use it?
So we're really excited. We have a whole bunch of launch partners with us for this today, including almost all the major tooling that customers would be using to launch and manage their functions. Amit, do you want to give us a quick rundown?
Yeah, absolutely. So all of our infrastructure and monitoring partners are all aware of this, and they're all integrating with this new capability. Today, we are happy to announce that partners like Datadog, Absagon, Lumigo, New Relic, SignalFX or Splunk, Sumo Logic, Tundra, Serverless Framework, Terraform, all of these partners have support for provision concurrency as of today.
So we have a question from chat from David R777, and they're asking about Cloudformation and SAM support. So can we talk a little bit about that?
Yeah. So Cloudformation and SAM will both be supported today. What you can do is you have a simple attribute that you associate with any version or an alias, and just tells you the number of concurrent execution environments you want provision on that particular alias or a version, and then you will basically, when you deploy the template or update your stack, you'll see the concurrency there.
So in a short sentence, great support for automation through partners, through the internal AWS tooling. So very happy
absolutely.
with that.
First-party support, third-party support. People can start playing with this right here at the end of today.
That's pretty cool. I love how now you have both provision concurrency and on-demand concurrency for things like Lambda and DynamoDB, and other services. So you can mix and match kind of what you like. One question I had is, what if I need more than the concurrency that I've provisioned? Do I get throttled or?
No, so it's completely transparent to you. So provision concurrency is going to give you a certain number of concurrency that you have pre-provisioned. However, as your function traffic comes in, it'll just continue to spin up functions beyond that. So from a function perspective, there's really no difference in how Lambda scales, in how your function's going to behave. Doesn't change how your code itself is really executed. Things should just continue to work like they've worked all along.
Yeah, and we want to give you the choice as a developer. You have both choices. You can say, my function, once it gets traffic beyond the provisioned amount, whether it should scale as like normal on-demand manner, or whether you want to throttle beyond that part, right? So if your application must have a certain guarantee in terms of its performance, then you don't want it to scale beyond a certain level. And so you have both choices as a developer.
Cool. Yeah. So I know that what a lot of customers do is that they do a lot of the initialization stuff, like initializing objects and SDKs and maybe retrieving some parameters from the parameter store, out of the handler. So that's part of what we tend to call cold start. So what I'm assuming is that all that part will be already done in my warm functions, right?
Yeah. So if you kind of look at sort of the anatomy of a cold start, there are two components to the cold start. There is the part that the system controls, which is to go get your code, download it, find place to run it, initialize the execution environment, all of that stuff. That's completely controlled by the Lambda system, and we continue to squeeze this portion of the cold start time down to by millisecond. I think the other more significant component of the cold start is what we call the initialization. That is code that you write outside the handler, the framework that you use, the various dependencies that you pull in with your code. And in our experience, that is the bigger component of cold start for most customers. So when you set provision concurrency on your function, what we do is we run all of the initialization up to those concurrency number. And now the function is initialized, it's ready to respond to your invocations right as soon as the invoke comes.
Great. And what happens when I don't need that concurrency anymore? We're going to just drop it?
Yeah, you
forget?
can spin it on down, and the environments will eventually potentially idle out, depending on what your concurrency looks like. But again, you could turn that knob up and down as you have actual traffic coming into your function, and it's not going to impact
right.
what's happening with that.
Can we talk a little about metrics? Like, are there new metrics that we have visibility into?
Yeah, we've provided like 4 new metrics in order to monitor provision concurrency. There are metrics to monitor how many concurrent executions you have that are using provision concurrency, how many invocations are running, whether you are spilling over in terms of like if you've configured a certain level and you have just more traffic in terms of that. So you will see all sorts of these metrics in your console, in CloudWatch, and everywhere.
Oh, that's amazing. Okay, now the hard question. How do we pay for this thing? What about pricing?
Yeah, so provision concurrency does add a new pricing dimension to Lambda. This is a dimension that we call provision concurrency. This is what you pay for how much ever concurrency that you configure for how long ever you configure it for. And you pay this price no matter what, whether your function is idle or being invoked. So that's the new provision concurrency dimension that we added. The existing dimensions of duration and requests are preserved. There is no change in those. So if your function is more busy, is running a lot of compute in that duration, you're going to be charged a little bit more than if your function is provisioned, but it's not running anything. The duration is at a lower price though, so it's at about 60% the price of what you would pay for on-demand. And so as a result of it, if you provision a certain amount of concurrency to your function and you're able to utilize it very, very well, it actually turns out to be cheaper for you.
Yeah.
So,
wow.
That's another important thing.
And I think that, and it's important to drive that home, that this is a new feature, a new capability of Lambda, that if you use it right and you use it well, you will save money on your function. So your performance will be better, and you'll save money. So that's an awesome kind of double benefit of using this. So again, I think people are going to be really excited once they start playing with this.
I love that. So
another big question is, when is it GA? What regions is it going to be available in?
So we'll be globally available in all public regions today.
Yeah.
And so again, you want to wake up tomorrow and fire up some provision concurrency, you'll be available to. You want to burn some midnight oil tonight and play with this, you can. We've got a bunch of blog posts and documentation. They'll be going out here in the next couple of hours, so you'll be able to see some examples of this and, again, get some further ideas about how it works.
Awesome. So I'm assuming it will work with any runtime, any programming language, Lambda layers, and all the other features of Lambda.
Exactly.
Yeah, it works seamlessly with all your existing function. You can do it for any new function or your existing functions.
Yeah.
And all you have to do is to basically set this number on your function correctly based on your demand, and soon thereafter you will kind of start seeing the performance.
And we see this being really beneficial specifically for interactive workloads, so APIs in general being one good example of that. But because you could turn it on per function, again, the granularity of being able to tune performance to certain functions that require more performance maybe than others means that you can be really specific about where you turn this on, where you don't turn this on, which is very similar to how security works in Lambda, how tuning memory works in Lambda, how a lot of things do, where that granularity becomes so beneficial to you and how you think about building serverless applications using Lambda.
And it sounds like we're going to reward customers that have really good metrics around their usage because they can provision the right amount of concurrency, get some savings there as well, right?
Correct.
Yeah, that's right. I think the way to think about this is, I think in the past we had this false choice, whether you want to go serverless and then you have to deal with the issue of cold starts and tail latencies. And if those are not acceptable for your application, the only choice you had was to either run your infrastructure on your own, run servers, manage capacity for them, manage all of the challenges that come with going back to the serverful world. I think with provision concurrency, what we have is within the controls of Lambda, you just have a simple knob to turn. You have a simple configuration to make. And unlike other providers, we really don't want you to think about instances, whole servers, and kind of manage all of the gunk that comes with doing that. And so we just want to give you this one simple control that lets you choose between the performance that you want and kind of have the right knob and dial for you.
I love that. I think I'll use it with a lot of APIs and RESTful things, but maybe even some like data processing or like even short-term data like MapReduce or ETLs where you need a lot of concurrency to finish the job as soon as possible.
Yeah, I mean, this also makes a lot of sense if you know that you're going to have a burst in traffic, because you can basically spin it up before that traffic comes, have those low latency invocations come and get dealt with, and then you can turn it back off again. So just like auto-scaling works for so many AWS services, A, you can, again, turn this on just when you need it. B, you can have it react to traffic as you go. So for those folks who are familiar with traditional auto-scaling, called traditional at this point, in like EC2 and things like that, you get some of the same benefits with this. So pretty cool.
Yeah, and we talked a lot about latency over here, I think, but the other thing we have not really quite touched upon is the scale and the burst behavior of Lambda, right? So what you can do is, for any function, version, or alias, you can configure an amount up to your account level concurrency limit. And what it does is, once the concurrency is ready for you, you can instantaneously use that concurrency. And basically, you don't get any burst throttles in that duration. So it provides this new scaling lever. So if you talk about like data processing workloads, if you're going to see a big burst of incoming traffic, what you do want to do is, ahead of it, you want to provision the right amount of concurrency, and once it's ready, you will not, you can just basically absorb.
So you can make it faster and cheaper at the same time.
Exactly.
I love when you can do that. Another question I had, so
there's one from Twitch that I'd like to grab. It's basically a most basic one. Someone got here a little bit late. They want to know what Lambda is, right? So we've been talking about Lambda. Why don't we talk a little bit about what Lambda does and how it works?
Yeah, we should. Yeah, so for those of you who are completely new to Lambda, which there are still a lot of folks that are completely new to Lambda, Lambda is a compute service here at AWS. We consider it a serverless compute service. And what that means is that there's a couple of criteria that we use for serverless here at AWS. The first being that there's no infrastructure that you need to run. This means no physical, no virtual, or no container orchestration that you yourself as a customer would need to manage. It should scale up and down automatically as traffic comes in or goes away from whatever it might be serving. It is going to have, we consider pay for value. So this means that if you're not using it, you're not paying for it. And in situations like provision currency, where we're telling you now have this knob to pay for better performance, you're paying for that value, and that's something you do. And then finally, high availability and security baked in. So with Lambda, you basically launch your application and basically what are considered function-sized chunks. These represent kind of very discrete amounts of logic that map back to an event source. And so you can build things like APIs and microservices and do data processing, batch processing, respond to all sorts of different events inside of your AWS account. IoT, mobile, there's just so many different things you can do with Lambda today. And it's a fairly different programming paradigm, but we find that it's one that, again, is very powerful.
Great.
Yeah, and don't you worry, chat. I know you're all concerned about the lack of stickers.
I know.
I might know someone that has some Sam stickers in his backpack, so we'll hook him up.
It's a new laptop, I'm sorry. It's a new laptop. I haven't had a chance to label it up yet.
Well, I'm going minimal here.
Yeah.
I love that.
Thank you so much for joining us. Thank you so much for sharing this for the first time with our Twitch audience. We're really happy to do that. And keep it right here, Twitch. We'll be doing this all day for the rest of the day and the rest of the week.
Awesome. Thank you.